friends, I am Vaibhav Srivastava from Vaibhav E-Learning Academy. Today we are starting a topic in physics, that is ray optics. Today we will try to cover as much as topics possible in one video, or maybe even complete the chapter in this video. So without any delay, let us start the topic. So here we have ray optics. I'll explain what ray is, but first, what is optics? So what is optics? So in physics, optics is the study of light. The study of light is called optics. Now, if anyone asks you what is light, what would be your answer? What is light? So the answer to this question may be light is the thing which makes the objects or which makes another substance visible to us. But that is very old and basic definition. The actual definition of light is the region of the electromagnetic spectrum, the light of the electromagnetic spectrum which is visible to us. The region of electromagnetic spectrum. So here, that region of the electromagnetic spectrum which is visible to our eyes, visible to us. So the region of the electromagnetic spectrum which is visible to us is called the light. So what is the electromagnetic spectrum? It starts from gamma rays. The first rays are gamma, then we have X-rays. Electromagnetic spectrum is nothing but just like a series of all the different rays which increase in the wavelength. So first gamma rays, then X-rays. Let me write that a little bit short. Gamma. Then we have X-rays. Then we have UV rays, ultraviolet rays. Then we have the Vibgyor rays, gamma rays, X-rays, ultraviolet rays, Vibgyor rays, then infrared rays, then electromagnetic rays. And then we also have one more, that is radioactive rays. So the order increases as the wavelength increases. So the wavelength increases, the order of the electromagnetic spectrum increases. Starting with the gamma rays, then the X-rays, UV rays. So this region over here, this Vibgyor, this is the visible light. Visible light. This is the only light which we are able to see from our naked eyes. It starts from 4000 angstrom to 8000 angstrom. Vibgyor full form we know it is violet, indigo, blue, green, yellow, orange and red. So the spectrum of light which is visible to us, that part, this Vibgyor is the part which is visible to us. So we can say that region of the electromagnetic spectrum which is visible to us is called light. So now we understood what is light. We understood what is optics. Now what about the ray? What is the meaning of ray? So we will not say a light. We will say a line of light which is called a ray. So here we have ray. What is ray? So a beam, not a beam, like a light source giving out the colors. So we can say a ray of light. A ray of light means we can say like this. This is the ray of light. This point is, this can be like the source from where the light is coming from, and the direction. This is the tail, this is the head. The head states which area or which direction is the ray of light going. Then the second one, a bunch of rays of light is called a beam. Now this term beam is also very important. A bunch of rays of light is called a beam. Imagine 1 ray, 2 ray, 3 ray, 4 ray, 5 ray, 6, 7, like that many rays are coming. So this one set is called a beam of light. So in one time many light rays are coming from a same source. From a same source many light rays are coming, so we can say a beam of light. So here now we understood the meaning of ray. Ray optics. Ray optics means the optics that is the study of light. Study of light as a ray, that is just one. We will be taking only one source of light and we will be studying about it in detail. So now optics has two branches. One is ray optics and one is wave optics. Our today's video is dedicated to ray optics. Now ray optics has two major parts. First part is reflection. The second part is refraction. We are going to start with the first part, that is reflection. So, reflection. So, what is reflection? We can commonly say in a small definition, the bouncing back of light is called reflection. So, the bouncing back of light is called reflection. To understand this term more better, we have to draw one diagram. So, let us draw one diagram and understand it. So, for the diagram, here taking this as a polished surface. What is this lines which I am drawing? So these lines are one of the most important things in the whole ray optics chapter, that these lines. So this is a polished surface. Polished surface is a surface which can reflect up to 96 to 97% of the light ray which is falling on it. So what they do is they take a polished surface, that is a mirror. A mirror is a very polished surface. Mirror, that both the sides are of the same like mirror type. What they do is one side they silver it, and after silvering it they cover it with a black color substance or black color paint. That is called silvering of a mirror, so that the light does not go back, because if both sides, if it is too much polished, you can say it acts as somewhat like a lens, or it can absorb all the light which is coming. So that is why they polish one side. So here we have to know so many terms. Let us take a ray of light is falling on the mirror. We can take a plane mirror. So this ray is called incident ray. Incident ray. What is the incident ray? The ray which is striking the mirror, any plane mirror or whatever. The first ray which is touching the surface. After the incident ray has touched the surface, we have to draw a normal over here. This is called normal. What is normal? A perpendicular drawn to the surface. So it is like wherever the incident ray is falling, at that point you drop a normal. So it means you drop a perpendicular, and the light goes like this, and this is called reflected ray. So this is the incident ray, this is the reflected ray. This angle is called angle small I, this angle is called angle small r. So this incident ray is represented by I. This normal is represented by N. This reflected ray represented by R. One confusion, reflected ray and refracted ray both are similarly denoted by R only. So here this is the angle of incidence. This is the angle of reflection. So angle of incidence and angle of reflection. What is difference between angle of incidence and angle of reflection? So here, when an incident ray is falling on the surface, we are drawing the normal. The angle between the incident ray and the normal is called the angle of incidence, and the angle between the normal and the reflected ray is called the angle of reflection. So this is how the reflection process usually happens in a plane mirror. Here we are talking only about plane mirror. So we have one property of light. We already know that light travels in a straight line. It always travels in a straight line unless or until the medium changes or it gets reflected. So here also, if the mirror was not there, this would have gone like this to infinity. But because of this mirror, this gets reflected. You now understood the process of reflection. Now this is how reflection happens. There are two laws of reflection. We have to remember them. Laws of reflection. Now what are the laws of reflection? There are mostly two and majorly two laws of reflection. The first law is the incident ray, reflected ray and normal. Here I means the incident ray, R means the reflected ray and N means the normal, lie on the same plane. And the second is that the angle of incidence is equal to the angle of reflection. These two are one most important laws of reflection which we have to remember throughout the journey of ray optics. So these are the two laws of reflections. So now we understood what is laws of reflection and what are reflections. So this is how the reflection happens. Now we are going to see one more topic which is called normal incidence, and in case of spherical mirror, how can you draw a normal? So first thing we are going to see what is a normal incidence. So normal incidence, let us take this plane mirror. If any incident ray I is hitting directly like perpendicular, it is already perpendicular on the surface, it is hitting and it is being reflected in the same. So this is also incident ray, this is also reflected ray. When you are drawing the normal, the same area you will get the normal. So this is also the normal. So this is the incident ray, this is the reflected ray, this is where the normal will be drawn. This is called normal incidence. Further in this video, regarding this normal incidence, so many topics are yet to be explained. So this normal incidence is very important term. When any ray of light is hitting directly perpendicular on the plane mirror, here we are talking about the plane mirror only. When it is hitting perpendicular, that when you draw the normal is also drawn same as perpendicular in the direction of the incident ray. So this is the incident ray. Here only you will draw the normal. The reflected ray, the ray gets reflected in the same direction as it came. It came like this, it will go back like this. So this is what a normal incidence is. One more point, that I said the first law, the incident ray, the reflected ray and the normal lie in the same plane. What is the meaning of this? So for example, this is our normal, we can take over here. This is the incident ray, this is the reflected ray, IR. So here if we are taking the board, this board as one plane, incident ray is also at that plane, reflected ray is also in that plane and normal is also in that plane. Which plane it is? It is in this plane. So if here you are taking this side incident ray, this side normal, this side the reflected ray. In one plane all the three rays lie. So that is the first law. And this we understood what is normal incidence. Now in case of spherical mirrors, so we will be discussing about spherical mirrors lately, but for example, you are taking this as a spherical mirror. If you are incidenting like this, how do you think will you draw the normal over here? Spherical mirror in the sense, maybe its outer side or inner side is being polished, but here we are taking the inner side is polished. So if the inner side is polished, it means the outer side is reflecting. Inner side is silvered and the outer side is polished, it will reflect. So this is the center of the mirror. So you draw the normal such that it passes through the center of the mirror. So here normal will be drawn something like this. See, now the normal, it is passing. This is the center of spherical mirror. So the normal is drawn such that it passes through the center of the mirror. You take this angle as angle of incidence. At the same angle, you reflect it back like this. This is the angle of reflection. If the normal is passing directly in between, then angle of incidence is equals to 45 degree. Angle of reflection is also equals to 45 degree. Hence, you can draw other normals like this. So, in case of spherical mirrors, you have to draw normal such that it passes through the center of the mirror. So, this is the two important concepts, how to draw normal on a spherical mirror, and the second one, what is normal incidence. So, these two are most important topics. Now, we will be discussing about mirrors. There are two types of mirror. First type is a spherical mirror and the second type is a plane mirror. First we will be discussing about the plane mirror. So here, plane mirror. Plane mirror. So let us take a mirror over here like this. This is our plane mirror. Okay. Now we have one object over here. Let us take a point object O over here. Now this distance is said to be x. Object is at here. Then in case of plane mirror, at the same distance the image will also be formed. I. This distance is also x. So this is one property of plane mirror. So in image formed by plane mirror, the distance, so here I can write the distance between the object and mirror is same as the distance between the mirror and image. So this is one of the most important point of plane mirror. The distance between the object and mirror is same as the distance between the mirror and the image. So from O to the plane mirror, the distance is x. Let us assume x is equals to 5 centimeter. Then the image will also be formed at here over 5 centimeter. So the distance between object to image will be 5 plus 5, which is equals to 10. So the distance between object and image will be 5 plus 5, 10 centimeters. So this is one main and important property of plane mirror. So now we are going to see the image formation by plane mirror. Our topic is image formation by plane mirror. So there will be two cases. First case, point object. So one very important thing you have to note, whenever you want to form an image, you have to take two rays of light from one object. So I'll explain you how and why is that done. Let us take, this is the plane mirror. We are drawing one axis over here, which is the center axis, we can say. In spherical mirror, it is called principal axis. Here, we are taking a point object O. To find the image of O behind the mirror, you have to take two rays. First, you take like this, first ray. Now you are like striking a ray on the mirror. You are striking a ray on the mirror. It is a polished surface. First, what you have to do, draw a normal over here. Done. Now what you have to do is you have to reflect it with the same angle it came. Okay. So here we can say that this is the angle of incidence, angle of reflection. Both the angles are equal. We took the first one. Now we take one more ray downside. Here again we draw a normal and we reflect it back. This is the angle of incidence over here. This is the angle of reflection over here. So now we saw that we took two rays. One we struck it up and then we reflected it. Second, we striped it down and then we reflected it. How did the image form backside? So here we can see that these two rays are diverging rays. What is the meaning of diverging? So converging in the sense it is coming to one point. Diverging means from one point it is going separate. So from one point it is going to two different paths. So these both are diverging. If the rays are diverging, you cannot form a real image. What you need to form? You need to form a virtual image. How to form a virtual image? Both the rays you have to produce backwards. So how do you produce it backwards? You take it like this. Same from here. At this point, both the rays are meeting. This is the image. So this is the object, this is the image form. You can produce it backwards more appropriately like this. Yeah. Here is the image. So the distance between object and the mirror is equal to the distance between mirror and the image. So this let us take x and this also let us take x. So object distance and image distance is same. Hence we found how did the object show in the, like how did we create the image of an object using a plane mirror. But these type of pointed object will not be too much useful because we will not be doing questions about pointed object. The main thing is we will be discussing about elongated object. So this was first, that is point object. What about the image over here? Wait, one more thing you can write. Image. Image is. Here we cannot describe much whether it is inverted, whether it is erect, whether it is laterally inverse. Because a point, if you reverse it, it is a point. If you downward it, it is a point. If you reflect it, it is a point. We cannot say whether it is elongated or diminished or magnified or whatever it is. We cannot say because it is just a point. We can only say it is virtual and of same size. Because the point did not elongate, the point did not go down. So we can say image is virtual and same size in the case of plane mirror for a pointed object. Now, second part we have is a after pointed object and elongated object. What is an elongated object? Second part over here will be about elongated object. Second one is elongated object. So elongated object. What is an elongated object? Over here we are taking a plane mirror. Similarly here a plane mirror. So in this plane mirror we are having the same axis, principal axis over here. We will be discussing what is principal axis in spherical mirrors. So here we have A, B. This is an elongated object. Now this elongated object, we have to form the image of the elongated object over here. How can we form? So to find the elongated object, you need to take two rays from both head and tail. We are taking point A, which we will see as head, point B as tail. So we take two rays. First ray we will be directly producing, that is called normal incidence. This normal incidence will reflect back, but we will not be writing about that. Second, one ray will go like this and it will be reflected like this. Here we are drawing the normal. Similarly, for B, we will be taking one B like this ray, which is normal incidencing, will come back. One more from B, it will take like this, put a normal and drop it back down. Now, A and B, we have to produce them backward because they both are diverging rays. So, this will be done like here, this will be taken like this over here. So, we draw the image like this. This is the part of A. Over here A. This B will be also taken, produced backward. This will be produced like this. So here we will be making A dash and B dash. So AB, this was the elongated and this is the reflected, that is the image. So that is how you form the image of an elongated object. Let us revise again what we did. We took point A and point B of an elongated object. We took the point A, we made two rays. As I said, you need at least two rays to make image of any object. One ray we took at normal incidence, second ray we took as incidenting and it reflected. We cannot form the image, real image, because they both are diverging. So we need to make a virtual image. So our eye will be somewhere over here like this. So from here we will be locating. Here we see that these both eyes are going different directions. So we try to produce it backward. So point A we produced like this, point B like that, and then we made A dash and B dash, and then we found the image. So here you can at least say one more point. Here it is still not satisfied whether the image is same, like it is as same or not, because see, the size is same. The size of both the images is same. We know that. So there is no magnification. One more point we get. Image is, first point we already know it is virtual. Second point we got that it is erect. So we can say it is erect. Virtual, erect. Then one more thing, it is same size. So the image is virtual because we produced it back. Image is erect, it is of the same, like erect means it is upright. Erect is also called upright. And it is of the same size. So if this is 5 cm long, this is also 5 cm long. And again the distance between the object and mirror is equal to the distance between mirror and the image. So this was about elongated object, but still one more thing is not clarified yet. So we will be taking one more case over here, elongated object only, but another case. Now let us keep it there only. Here we are taking one more plane mirror. Similarly, we are making one principal axis. We are having an object like this. This is also elongated. Let me make it a little shorter. This we are saying A, point A and point B. Now we need to form the image of this object over here somewhere. How do we do? We take the same two rays. One, we take it as normal incidence, which comes reflected back. Second, we take like this, make a normal, reflect it upside. Then B we take like this, another we take like this, make a normal, reflect it back. Now we need to produce it backwards. This one being produced backwards over here, we get the image of A dash over here. Now for B, B is same like that, and this is being produced over here somewhere. So this is B dash. So we got the image once again. So here we took an object AB, and A we made two rays to fall from A, one like this, because they both are diverging. So we need to produce them backwards. On producing backwards, they both meet at this point and they both meet at that point. So B we make a B dash, A we make an A dash, and then we get the object as AB. So we got one more point. Here the object is tilted towards the right, but here the object is tilted towards, the image is tilted towards the left. So we can say one more thing, that image is laterally inversed. So these are the 4 points of how the image will be formed. The image is virtual, it is erect or upright. See, it is virtual, it is erect, it means it is like upright only. It is of the same size like this. It is laterally inversed. It means that the left is right, right is left. So this was about image formation by plane mirrors. So we had 3 cases. One case, first one which was a point object. Second case which was elongated. Third case elongated but with a direction. We have a direction over here. Now we are going to start another topic, that is image formation by a series of mirrors. Number of images formed actually. So number of images formed by a plane mirror. Number of images formed by a plane mirror. Here also we will be having so many cases. So let us start with case number 1. When the mirrors mirrors are parallel, so that is number of images found by a plane mirror, one case when the images are parallel. Let us take two mirrors over here. This will be saying mirror M1, this is mirror M2. So we are polishing this side over here. Here we are polishing this side over here. So now we have polished two mirrors successfully. Taking an object over here. We are taking a point object only. Object O. Now we are assuming that the distance between here and here is 1 centimeter. We are assuming 1 centimeter. Not actually, but it is 1 centimeter we are assuming. So first, form the image of this object in the first mirror. What we do? We take one ray like this, second ray like this, which gets reflected. This one being produced backwards forms an image over here. Here is the image. Distance between these both is 1 centimeter. Okay. Now the same thing we have to do this side also. Like this. So here the image formed like this. Here is the image I2. Here we can take I1, I2. Same distance over here also, it is 1 centimeter. Now one more important property which you have to learn about the mirrors is that the image acts as object for the another mirror. So this is one important thing, 1 centimeter, I1. So here this I1 will act, so here actually this I2 will act as an object for this mirror M1. So this for mirror M1, this will be the object. So it will form the image of this I2 over here. How will it form? Here the same, we are taking two rays over here like this. One it is going and it is forming till here. Alright. Second one, we are taking it as very high. This mirror is extendable till here. From here we are drawing the rays at coming like this over here. So this is I3. What is the distance from I3 to I2? It is 1 centimeter plus 1 centimeter plus 1 centimeter. Why? Because the object distance. Here the object is this. This is not the object. The second image forms as the object for the first mirror over here. So 1 plus 1 plus 1, it is equal to 3 centimeter. So here 3 centimeter. Now similarly, this mirror forms the image of this side. So for I3 it will form an image over here. One line will come like this, one line at very high, there will be a mirror over there. So from there it will reflect back from somewhere and it will come over here. This will form I4. So now this is the image. So 1 centimeter, 1 centimeter, 1 centimeter. This will be 3 centimeter. Now this I3 will become one object for the second mirror, or you can take this I4 to be the object for first mirror. Now here, this distance to this distance, 3, 4, 5. This will form one image somewhere, that I5, which will be the distance of 5 centimeter. Then that same thing, that 5 centimeter again will form an image over here as I6. That will also be 5 centimeter. Then again 7, then again 8. So if the mirrors are parallel, the number of images formed will be infinite. There will be infinite number of images formed, but just one thing, that they are like, we cannot say like their luminescence, that is their brightness will be low. It will be fading slowly. So the first image will be more prominent, the second image will be less prominent, then the third one more less. So it will be deviating, like the light capacity will be deviating slowly. But actually in theory, number of images formed is infinity. This type of mirrors are present in the barber shop. So if you go to a barber shop, two mirrors are placed parallel to each other. So the images formed will be infinite. So that's why you can see a long number of images formed. Infinite number of images will be formed. So this is the case number 1. Number of images formed by a plane mirror when the mirrors are parallel. So the number of images formed will be infinity over here. Now this was the case number 1. We have one more case. Now this case is little bit interesting case. When the mirrors are when the mirrors are inclined at an angle. Second case, when the mirrors are inclined. So when the mirrors are inclined. So here we need to use one formula or one trick, we can say. This is one trick only, but the actual method is actually very long method. So let me explain the actual method, then we will explain you the trick method. I'll do the trick first. So if 360 by theta. Now what is theta? I'll explain theta. So if 360 by theta is equal to n, and this n is even. First we'll take odd itself, and the n is odd. Then if symmetrical or asymmetrical, n minus 1 is equal to number of images. This is the case number 1. If 360 by theta is equals to n and n is odd, then either symmetrical or asymmetrical, the number of images will be n minus 1. Here, one more case. This is case number 1. Case number 2. If 360 by theta is equals to n, which is even, then if asymmetrical, number of images is equals to n minus 1. So if asymmetrical, the number of images is equals to n minus 1, and if asymmetrical, number of images is equals to n. Here it will be symmetrical. So this is the formula. If 360 by theta is equals to n, and if n is an odd number, then if symmetrical or asymmetrical, n minus 1 will be the number of images. And if 360 by theta is equals to n, and that n is an even number, then if it is symmetrical, the number of images is equals to n minus 1. If asymmetrical, number of images is 1. Now what is asymmetrical, what is symmetrical, we'll be discussing that now only. This is the trick actually, you can say. Now I'll explain the main, what is the main method, how to do that. So let me write that formula over here. 360 by theta is equals to n. If it is odd, then both the cases it will be n minus 1. If it is even, 360 degree by theta is equals to n. For symmetrical, it is equals to n minus 1. For asymmetrical, it is equals to n. So this formula we are noting over here. So first, let us take, we have two mirrors over here. They both are inclined at an angle of 60 degree. Okay, let us take 60 degree. Here one more important case will come over here if it is 60 degree. Let me take another over here, for example 40 degree only, sorry 60 degree. So that 60 degree, we are taking one image over here, object is over here, O is over here. Now we draw like a line over here like this, which divides this angle into two. One is 20 degree and one is 40 degree. This is mirror 1, this is mirror 2. How to find the number of images? So the thing is, we draw M1 over here, M2 over here. What is the angle? 20 degree. M2, what is the angle? 40 degree. So what is the sum of these both? The sum is 60 degree. So what you do is, you put the M1's angle and M2's angle and you do the sum in the between. Now we need to add 40 and the total angle. 40 plus 60 is equals to 100 degree, and 60 plus 20 is equals to 80 degree, and again their sum is equals to 60 degree. Now you have to keep on adding them until it reaches either 180 or more than 180. Now 60 plus 80 is equals to 140 degree, and 60 plus 100 is equals to 160 degree. Again we can continue it with 60 over here. 60 plus 160 is equals to 220. We have to stop it. We should not do it further. 140 plus 60 is equals to 200. So we stop it over here. So what is the number of images? 1, 2, 3, 4, 5, 6. 6? No, it is wrong. Because in any case, when we are doing like this, if we get a set like this, what does this set represent? Here we have 140, 160, 60, which is equals to 300 plus 60, which is equals to 360. When you are doing like this, and if you get the sum of these three as to be say 360, you will not take two separate. Instead of that, you will take only one. Usually, when for example we have mirror 1, mirror 2, let us take one is at an angle 10 degree, 20 degree. When we are adding them, so here it is 30 degree, then here we have 50, here we have 40, then again with 30, 70, 80, again with 30, 110, 100, and then again with 130, 140, like that will continue. But there will never be a case where it will be 360 degree. So it will continue until it reaches 180, it will stop. That's it. So number of images will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, whatever it is. Number of images will be like that. But when this type of case comes where the 3 are actually equal to 360, instead of taking both, we have to take only one. So the number of images is 1, 2, 3, 4, and instead of 5, 6, we take only one. Number of image is equal to 5. 1, 2, 3, 4 and 5. So this is the actual method how to solve this. What if we are taking instead of 20 degree, 40 degree, we are taking like same 30 degrees and 30 degrees. So how do we solve that? We are going to see that. Number of image if asymmetrical. See, now what is symmetrical, asymmetrical? When it is 60 degree, symmetrical means 30, 30. Both are same on equal side. Asymmetrical means one side is less, one side greater, or one side greater, one side less, just like that. So in asymmetrical, number of images was 5. Now let us take symmetrical. So M1 is equals to 30 degree, M2 is equals to 30 degree. 30 plus 30 is equals to 60 degree. 30 plus 60, 90 degree. 30 plus 60, 90 degree. Then again, we have over here 60 degree. 60. 9 plus 6, 150 degree over here, 150 degree over here. Now again, we have here 60 degree. So 60 degree over here, it is equals to 60 degree. It will be greater than 180, so we are not going to take that. Now check this case whether it is giving you a total of 360. 150 plus 150 plus 60. 5, 5, 10, 60, 360. We are getting 360, so we should not take 2, we should take only 1. Number of images 1, 2, 3, 4, 5. So number of images is equals to 5. Now this was the actual method how to solve it. But if you want a trick, this trick we are going to check it now. So 360 degree by theta is equals to n. So what is the theta over here? What is the sum of 2? It is 60 degree. So 360 degree divided by 60 degree. So here theta is 60 degree, right? Here we will get 6. So here 360 by 60 degree is equals to 6. Here we are getting the answer to be n is equals to 6. So here it is even 3. So here now it is 360 by 60 degree is equals to 6. So for example, if we are taking asymmetrical over here, number of images we are getting 5. So asymmetrical or here if we are taking symmetrical, number of images 5. So 360 by 60 is equals to 6. 6 is an even number. So if it is asymmetrical, we are taking only n. So symmetrical means we are taking n minus 1. So it is equals to 6 minus 1, which is equals to 5. So this is how you get the answer 5. So if it is symmetrical, the number of images between them is 5. Mostly if you take it for symmetrical, you will get your correct answer. Asymmetrical, sometimes this formula will not work. You have to use your original formula. Like here asymmetrical, if you are taking, you will get the number of images as equal to 5. But it should be n. So some cases this will not work perfectly. But the main solution is we can use that formula M1 and M2. So this was about how to find the number of images. First case was when the when the mirrors are parallel, and second case when the images is inclined at an angle. Now we are going to start another topic over here, which is spherical mirror. So let us see the spherical mirror. Now what are spherical mirrors? The mirrors which are formed by like cutting off one part of sphere. So now our topic is spherical mirror. Spherical mirror. So let us take like this one sphere. This is not a circle, it is a sphere. So we are silvering some points over here, like half here. Let us take half, it is silvered inside, half it is silvered outside. So if you are cutting one part of this, we get this over here, which is like this. If we are cutting from here, we get something like this. Let us silver it inside. So these two are spherical mirrors. So spherical mirrors. So this is one mirror, this is another mirror. So we'll be naming them and we'll continue our this chapter. So here spherical mirrors are of two types. First is convex mirror. Second one is concave mirror. What are convex mirror and what are concave mirror? So let us start this topic. So here let me draw one mirror like this. So this appears to be a sphere, right? Like this. So we have cut a portion of the sphere. So this is one spherical mirror. This type of mirror, which is like it is like a cave inside, right? We are producing a beam like this. It is like the beam is going inside a cave. So this is called concave mirror. This is a concave mirror. We are producing a light inside a cave. So this is concave mirror. The same mirror, if we are silvering it inside rather than outside, we are producing a ray of light like this. It is bulged out, so this is called convex mirror. An easy way to remember, whenever a ray of light is going inside a cave, it is like concave mirror. When it is bulged outside, it is called convex mirror. So these are the spherical mirrors. So now these spherical mirrors, because of the introduction of these things, spherical mirrors, we have to learn a few more terms regarding the mirrors. So let us see some terms regarding spherical mirrors. So we are going to start one by one. Let us start with the first one, which is called pole. Now what is a pole? So we have to write the definition of each and everything to understand it better. What is a pole? The center point of the mirror is called pole. So the center point of the mirror is called pole. We have a mirror like this over here. It is a concave mirror because the ray of light will go inside. Here, this point over here is called pole because it is the center of the whole mirror. So this is a pole. The center point of the mirror is called pole. This is one thing. Second one, we have principal axis. Principal axis. Here this principal will be like PRINCIPAL, not principal, principal axis. So this axis is the line connecting / joining having focus and center of curvature. Center of curvature in it is called the principal axis. So actually here you have to understand, here what is focus and what is center of curvature I will discuss now only. But here this line, we always draw one line like this, right? This line is called the principal axis. On this principal axis only all the objects are kept. This is the principal axis. Now, our first term over here, let us take center of curvature now. Third one, which is center of curvature. What is center of curvature? If you look at a mirror like this is a spherical mirror, right? This appears to come from a sphere, right? So the center of this sphere should be this, right? So this distance is called, this point over here is called center of curvature, and this distance is called radius of curvature. So pole is represented by P, capital P. Principal axis, we are not representing it because we are directly drawing it. Center of curvature represented as C. Center of curvature, the center from which the mirror has been cut. So we have cut this part, right? So this part over here is called the center of curvature. And here also we have radius of curvature over here. Radius of curvature. What is radius of curvature? The radius of curvature is the radius of the sphere from center of curvature to the pole. The distance between center of curvature to the pole is called the radius of curvature. So the radius of the sphere, this is represented by R. So here we have the first four terms. First one, the pole. The center point of the mirror is called the pole. Second term, principal axis, the line connecting or joining or having both focus and center of curvature in it. Center of curvature is the center from which the mirror has been cut. Radius of curvature is the radius of the sphere. These are the first four. Then we have one of the most important part of the whole mirror, that is focus. Now, fifth one, focus. Now this has some definition which is actually lengthy. So, the point from which, at which the rays of light either directly or appear to meet is called focus. So the point at which the rays of light either directly or appear to meet is called focus. So what is this focus? Let us take over here the mirror. It is a concave mirror over here. So we are taking this point, for example, as a focus. Okay. So when a ray of light is going like this, so actually if we are taking a case of a concave, then all the rays of light actually pass from the concave focus only, like this. So the focus is the point at which the image can be drawn. Like this point is very important point because there only they either meet or appear to meet. So this is directly meeting, but where do they appear to meet? For example, we are taking a convex mirror. This is the principal axis. Here the focus will be over here. Why? Because the sphere should be completed this side. So the focus is that side. So the rays, it falls on this and gets reflected. Here also it falls and gets reflected. But it looks like it is trying to go over there. So that is, they appear to meet to the focus. Here they do not meet actually, but they appear to meet. One more case, for example, if a ray of light is coming like this, it wants to meet the focus, but it is being reflected like this. So here also it appears to meet to the focus. So this is about the focus. So the point at which the rays of light either directly or appear to meet is called focus. Now the sixth one we have over here, which is the focal length. What is focal length? It is represented by small f. This is represented by capital F. So what is the focal length? The distance between pole and the focus is called the focal length. So this is the mirror, this is the focus, so this much is the focal length. That's right, that is very basic concept of a focal length. Now focal plane, that is one more thing which is called focal plane, the plane in which the focus lies. So let us take, this is our mirror, this is our principal axis, this is our pole, this is our center of curvature, this is our focus. If the rays are coming parallel to the principal axis, they get reflected and they pass through the focus. Okay, it is when they are coming parallel to the principal axis. What if they are not coming parallel to the principal axis? So if they are coming like this, or else instead of like this, we can take it, they are coming directly parallel like this. If they are coming like this, they do not go through the focus, they go like this. Another ray like this. But their focus is somewhere over here only. They both will, at least at one point, they will intersect at each other. That one point is called focus. So we can say that all the focuses or foci lie in the same plane. So this will be one plane. In this plane, either here, anywhere the focus will lie, but it will be only one small plane in that the focus will lie. That is the focal plane. Now, these were all the important terms related to the spherical mirror. Now comes one of the most important topic which will cause a lot of confusion if you did not do it properly. That topic is sign convection. What is sign convection? We have to read 3 sign convection. Sign convection. There are 3 sign convections which you have to remember them because they are very important. First one, all distances are measured from the pole. All distances are measured from the pole. Okay, this is the first one. The direction of incident ray is taken positive and others negative. This is the second point. And the third point, the height above the principal axis, the height above the principal axis is taken positive and below negative. So first sign convection, all distances are measured from pole. Second, the direction of incident ray is taken as positive and the other is taken as negative. The height above the principal axis is taken as positive and below as negative. First point, let us take, here we have our mirror. Let us take the object is over here, object. So to find the distance, we do not take object to pole. We have to take the distance like this, x. That is the first sign convection. This is not that important, but it is important only. Second one, but comparison to these 3, it is not that important. Second one, direction of incident ray is taken as positive and others negative. So, for example, the incident ray is coming like this. Then anything which is in that direction, it is positive. Anything which is coming to this direction, that is negative. This is most important when we are discussing about image formation. And when we are doing some numericals, when we are doing some problem, this is very important that when we are taking it that way. This will be very important when we are discussing about the mirror formula and the lens formula. At that time, this will come very handy. So this is actually taken as positive and others as negative. And third one, the height above the principal axis. This is the principal axis. Anything on top is taken as positive, anything below is taken as negative. These three are the sign conventions. So these three are very important. All distance are measured from the pole. The direction of incident ray is taken as positive and others negative. The height above the principal axis is taken as positive and below the principal axis is taken as negative. So I think we'll stop the topic till here for now. So this was very long video and I hope you understood so much things from this. In the next video, we'll be discussing about the image formation by convex and concave mirrors. Then we will be discussing about mirror formulas and we'll be doing a lot of numericals on them. So we'll see you next time. After that, we'll be also doing about the refraction, topic refraction. So we'll see you next time with the next video. Hope you enjoyed it. Do like this video. Subscribe to this channel if you are new. See you next time in the next video. Thank you and goodbye.